Be strong.
Greetings everybody at home. Welcome to the next lesson on mathematics. The topic is on sequences, patterns. If you look at the mathematics curriculum, it is what we call the spiral curriculum. Whatever you learn in grade 9, which I'm teaching now, is actually being taught in grade 1, grade 3, grade 5, grade 7. So today the topic is on sequences, sometimes called patterns. Similar to this, we have shapes. When we first started mathematics, we did not introduce you with numbers, we have shapes. So this is a square, triangle, circle, and the pattern goes on. Square, triangle, and they ask you to fill in that blank. What is the shape of that blank? And if you follow the pattern, you see that, oh, it's going to be a circle. Then you put in a circle there, and that's it. So you see there, and you know. You haven't learned the multiplication tables yet, but you know from this number to this number I need to add 3, and from this number to this number I add 3. There you go. That means every number, every consecutive number, you add 3, and indeed therefore the next number must be 12 plus 3, 15, and the next number 15 plus 3 is 18. So this is a review. This is what you have done in terms of sequences or patterns. So you've done this in grade 1 and 2, possibly in kindergarten, and you've seen this also in your grade 7 and grade 8. In grade 9, we revisit this topic of patterns, of sequences, but perhaps we dig deeper. We go deeper into it by finding other things in terms of sequences and patterns. So we'll start with if you recall the probability question that I gave you, in the last chapter we did probability, we did tossing of coins, and there was one question that I asked you about this which I did not tell you. So now let's go back again. One coin, I flip, I either have head or tail. So number of coins and the possible outcomes. I have one coin. The possible outcomes are 2, either heads or tail. We have done this. Then if I have 2 coins, one coin, another coin, I will have what we call what are the possibilities. I can have with one coin either head or tail, and with another coin I can have another head, another tail, another head, another tail, and so this branch, head, head, I can have a possibility of head, 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 tail, tail, head, and tail, tail. Meaning that with 2 coins, I can have 4 possibilities. 1, 2, 3, 4. You recall, I ask you now, instead of having 2 coins, I have 3 coins. What are the possible outcomes that I can have? So you remember drawing the probability tree. First coin. Second coin. Now I have the third coin coming in. Head, tail, head, tail, head, tail, head, tail. And so with every one of them, head, 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 that's one possible outcome. Head, head, tail, head, tail, head, head, tail, 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 head, head, tail, 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 head, tail, 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 head, tail, tail, tail. So this is for 3 coins, and all the possible outcomes, how many are there? 1, 2, 3, 4, 5, 6, 7, 8. So with 3 coins, I can have 8 possible outcomes. We have done this already. I'm just reviewing. What about if I have 4 coins and I don't want to do that? I don't want to draw the probability tree. I want you to decide what number is this? And a lot of you can give me the answer because you saw that from here to here is times 2. From here to here is times 2, and therefore you know that I need to multiply by 2 to get 16, which is the possible outcome for 4 coins. And if indeed you were to draw the probability tree, you will get 16. So this is good, times 2, times 2, times 2, which is correct. If I ask you for 5, you know the answer is 32, 16 times 2, which is good. But now I'm going to ask you what is about 10, how about 11, how about 69, how about 73? We cannot, we must find the nth term. So for 1 is 2, for 2 is 4, for 3 is 8, for 4 is 16, and so how about for n? Now this is algebra coming in. The n stand for a coin, number of coin. It could be 16 coins, it could be 80 coins, it could be 23 coins. N is just a letter. We need to find out, if it is n, what is this formula, so that we can straight away get the answer. So this is your task. Prior to this, just now what you did was, you look at this way, times 2, times 2, times 2, which is good, but I said that it's too long if you do that. Now I'm teaching you, if you can cut across and see whether there's a method to do it. So you look at 1 to get 2, 2 to get 4, 3 to get 8. You have to think of something. Oh, maybe in your mind say, oh, I just multiply by 2. This could be one of your hypotheses, which is okay. You look, but it has to be a pattern. It has to go across. If this is multiplied by 2, this one also multiplied by 2. Let's see. 2 multiplied by 2 is 4. Is correct. So far so good. Let's try again. 3 times 2, oh no. That means wrong. Because it doesn't follow already. It has to follow a pattern. Have to be everything the same. Therefore, this one we decided wrong already. So this one cannot be times 2. So you got to look again, look hard and think, and then through experience, through a lot of work that you do, you should be able to see that this number and this number are related. It's 2 to the power of n, right? So look at this. If this is 1, this one is 2 to the power of 1. This is 2. I do 2 to the power of 2, 2 squared. 2 squared is 2 times 2 is 4. So far so good. 3, 2 cube. 2 times 2 times 2. That's 8. So far so good again. How about this one? 2 to the power of 4. 2 times 2 times 2 times 2. And you get 16. Therefore, it looks good. Therefore, what it says here, whenever I have an nth term, it is 2 to the power of n. Based on this, 2 to the power of 1 is 2. Maybe I write it here. There you go. The number 1 is here. Number 2 is here. Number 3 is here. Number 4 is here. N is here. That's the pattern. Okay? So this is one way of pattern. So the pattern is as 2 to the power of, and you can get the answer. So now if I ask you, what if I have the 15 coins? How many possible outcomes? 2 to the power of 15. Meaning 2 times 2 times 2 times 2, 15 times. Many, yes, it's a big number. But at least you don't have to go through every single one of them. Okay? So this is now today we're going to learn the next part of sequences is to find the nth term.
Be strong. Be strong.